So we are starting a new unit. We're on unit 11. And this unit is going to be all about something called binomial expansion. Okay, binomial expansion. We will finish this unit this week. Okay, binomial expansion. Your test for this will be the Friday after spring break. Been over that a couple of times already. So, first off, can anyone tell me what is a binomial? What is a binomial? A binomial is when you have two terms. Okay, a trinomial is 3 terms. A binomial is 2 terms. Okay? Binomial expansion. What would it mean if I said to expand something? What does it mean to expand? Spread out. Okay, binomial expansion. So we're going to be working with 2 terms, and they are going to spread out. Okay, I don't necessarily want to make bigger, okay, but we're going to spread them out. We're going to expand them. So, for example number 1, I would like you to expand, what is x plus y to the 0 power? What is x plus y to the 0 power? What is anything to the 0 power?
Uno.
1. Okay, what if I asked you to do x plus y to the first power? How would you expand x plus y to the first power?
X plus y.
Just x plus y. Now let's try x plus y squared. X plus y to the second power. For this one, you probably need to write it out twice. So x plus y times x plus y, and you can just do it on the side of your paper. Okay, if you multiply those together, you would FOIL. You'd get x squared plus xy plus another xy plus y squared. You combine your like terms. That would give you x squared plus 2xy plus y squared. Do we all understand how I got that? Okay, so I'm going to write this out. So x squared plus 2xy plus y squared. So this is called binomial expansion. Now, what if I asked you to expand x plus y to the third power? What would you have to do? We would have to take this whole thing and multiply by another x plus y. Okay, the easiest way to do this is usually by old school multiplication. You could use the boxes, you could use the rainbows, however you choose. Okay, old school multiplication would be you multiply y times y squared, which gives you y cubed. Y times 2xy gives you plus 2xy squared. Y times x squared is x squared y. If you remember when we did old school multiplication, you always put a plus 0, skip over a space. X times y squared gives you plus xy squared. X times 2xy gives you plus 2x squared y. And then finally, x times x squared is x cubed. You add everything together. That would give you x cubed. 1 and 2 gives you plus 3x squared y. Plus 2 and 1 gives you 3xy squared. Plus y cubed. Tyler. So if I write this out, you would get x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay, that is the binomial expansion of x plus y quantity cubed to the third power. You can probably guess what the next one's going to be. X plus y to the fourth power. Now, I'm going to give this one to you. Okay, I'm not going to make you do the old school multiplication. X plus y to the fourth power is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. And you would get that by, again, taking this one, multiplying it times x plus y again. First thing I'd like you to notice is I'm going to give you patterns here, okay? Today is all about figuring out what are the patterns in binomial expansion and then using those patterns instead of having to actually multiply and multiply and multiply and multiply, okay? So we're going to find the patterns and we're going to be able to use those patterns to get answers instead of just multiplying a million times. First pattern that I'd like you to notice is the number of terms, okay? How many terms are in the expansion here? One term. How many terms are in the binomial expansion to the first power? Two terms. How many terms are in the binomial expansion to the second power? Three terms. How many terms are in this binomial expansion? Four terms. And 5 terms. What do you notice about the number of terms in each binomial expansion? It's increasing. But say it again, Thomas, a little louder.
It's always one more than the exponent.
Exactly, okay? Term number, or excuse me, number of terms. Number of terms is always, and this works for all binomial expansion, number of terms is always one more than the total exponent number. Okay, always. If your total exponent number is to the 0, you're going to have 1 term. If your total exponent number is to the third, you're going to have 4 terms. You always add 1 to figure out the total number of terms. Okay, so for example 2, some of your questions are just going to be this simple. If I gave you x plus y to the 10th power, how many terms would this binomial expansion have? X plus y to the 10th power would have how many terms? 11 terms. Okay, so simply being able to know whatever your total exponent number is, you add 1 to that, that's the number of terms. Okay, number 3. Also relatively simple. X plus y to what exponent value would have 23 terms? X plus y to what exponent value would have 23 terms? Do you add 1 or do you subtract 1? Subtract 1. Okay, you have to be able to go forward and backwards here. Okay, so if I give you the exponent value, you have to tell me how many terms there are. If I give you the term numbers, or the number of terms, you have to go backwards. So this would have an exponent value of 22. Questions on how I did any of that? Not too bad, hopefully. Okay, so far I've given you up to x plus y to the 4th power. The next question I'm going to ask you, for example number 4, you probably need about a half sheet of paper. So if you don't have that much left on the page you're on right now, you might want to switch pages. Okay, so you'll probably want to flip over pages. For example number 4, I would like you to expand, it's okay, x plus y to the 5th power. Expand x plus y to the 5th power. And this is going to be the one that I'm going to show you all the different patterns that we can possibly find here. Okay, x plus y to the 5th power. So we're going to write some steps. The first step is you want to figure out the number of terms. Okay, so if this is an x plus y to the 5th power expansion, how many terms will it have? 6 terms. Okay, and the first thing you want to do is I actually want you to put out 6 spaces. Okay, so 1, 2, 3, 4, 5, and 6. Sorry, I made these first ones a little too large. So you first want to put out the number of terms and their spaces. Then we're going to be kind of flipping in between 2 pages. Okay, I'm going to look back at this one, and I want you to notice, what are the x's doing? What are the x's doing as far as their exponent value? What is this exponent value here? What's the exponent on this x? A 1. This is x to the what power? Is it x to the 1st? If there's nothing there, x to what power equals basically nothing there? X to the 0. Okay? I didn't draw that in there because eventually I would drop it. But I do want you to notice that it's x to the first and then x to the 0. What happens here? X to the second, x to the first, x to the 0. X to the third, x to the second, x to the first, x to the 0. What do you notice about the exponent values here? They are decreasing. Okay? So the first thing you're going to do, or the next step you're going to take, first you're going to put in the number of terms. Then second step is you're going to put in first term decreasing. Okay, and when I mean decreasing, I mean its exponent value is decreasing. Now, how do I know, where do I start? If you look at these, how do you figure out where to start? The x exponent value, do you see any correlation between the x exponent value, the first one, and the original problem? The first exponent number is the same, right? So the first exponent always starts with the total number of the problem and then goes down from there. If it was to the third power, we start with x to the third. Total binomial expansion to the second power started with x to the second. So first term decreasing, and it starts with what? Start with total exponent value. So start with the total exponent number. So what is this first one going to have an x exponent be? X to what power? The fifth. Then we're going to decrease x to the fourth, x cubed, x squared, x to the first, x to the 0. Now, eventually, right, we're not going to have to write x to the first. Okay, you're going to drop the 1, and eventually you won't write x to the 0. But I would like you to write the zeros so that you have an x that goes in every single spot. Okay, that way it just helps you to make sure you did all the problem. Then, look at the other exponent. Okay, look at the second exponent value. What do you notice about its exponent value? It starts at what? This is y to what power? 0. Then y to the first. Y to the 0, y to the first, y to the second. Y to the 0, first, second, third. What are you noticing about the y exponent value? It is increasing. Okay, so first thing we did, we put in our first term was decreasing. Second term, okay, second term is doing what? Increasing. Second term, increasing. And you always start with what power? Start with 0 power. So, then I'm going to put in my y exponents. So, y to the 0, y to the first, y squared, y cubed, y to the fourth, and y to the fifth. Another thing that I'd like you to notice is the sum of the exponents. Okay, if you add together the two exponent numbers. Exponent totals, what do you notice?
They all equal 5.
Okay, the exponent total at any location, okay, at any term location, what's important about the 5 here?
The exponent.
It's the exponent total, okay? So at any location, exponent total will add, at any location, the exponents add to total of the original problem. Okay, so that's a way for you to kind of check your work. Okay, at any location, 5 plus 0 equals 5. 3 plus 2 equals 5. 1 plus 4 equals 5. You can check to make sure you have the right exponents by adding them together, and it will equal the sum here. Okay, if you add them together, they always equal the total. Then the last step here, okay, and well, almost the last step, sorry, I lied. It's not exactly the last step, okay. The next step, step 4, is to put in something called Pascal's triangle coefficients. put in Pascal's triangle coefficients. What are coefficients? Coefficients are what? Coefficients are the numbers in front of terms. So if you go back and look at these coefficients, this first one was a 1. What are these coefficients? What are the numbers in front here? 1 and 1. 1, 2, and 1. 1, 3, 3, and 1. What are you noticing here? What's the pattern? What patterns you noticed? Very close, right? First off, the first term is always a 1, and the last term is always a 1. Okay, if you look at the first term and the last term, they're always 1s. Do we see that? The second term, though, Sarah was right here. The second term, its coefficient matches the exponent number. So the second term on a fourth expansion is 4. The second term on a third expansion, its coefficient is 3. Okay? Second term on the expansion of 2, its exponent is 2. Okay? So we can start to fill these in. But there's actually a pattern, okay? There's something called Pascal's triangle. You guys are going to get one of these handouts. Okay, so I want you to take one, pass them back. Take one, pass them back. You guys will get to use these handouts. You want to keep them. Okay, I want you to keep them. You can use them for this entire unit. Also, on your test, I will give you a blank handout like this that you can use, you can fill in to use on your test. Okay, so take one, pass them back, and I'm going to help you figure them out. Okay? Can you pass me those ones? So, if you look at this, yeah, pass one there, thank you. Yes. A lot of them, yeah. So, on this handout, it says Discovering Patterns. I will give you a blank one of these for your test. The first one, somewhere a long time ago, there was a gentleman whose last name was Pascal. He discovered that there is a pattern in binomial expansion with the numbers in front. The way that you find that pattern is you always start with 1. So you guys are going to fill this in with me right now. Okay, so always start with 1. Then we're going to add whatever number these two together. So since there's 0 here, 0 plus 1 gives you a 1. 1 plus 0 gives you a 1. There's nothing outside here. Plus 1 gives you a 1. What do you think this middle number is going to be? A 2. So you're adding the ones before it together, and a 1. It always starts with 1 on the outside. What do you think your next one would be? 3. Add these together. 3, 1. Keep filling this in. Okay, what would my next level be? 1, 4, 6, 4, 1. Keep going. 1, 5, 10, 10, 5, 1. These are something called a palindrome. Okay, a palindrome means it's the exact same front or back. Okay, if you read it going this way and this way, they're like mirror image of each other. You can keep going on this because yes, we need to. 1, 6, 15, 20, 15, 6, 1. I'm not going to fill in any farther for you, but I would recommend writing it because eventually you will need farther of this. Okay, you don't have to at this moment, but do it when you have time. So let's at least go up to here. Now, we're going to put in our numbers from Pascal's triangle, our coefficients from Pascal's triangle. There's 2 different ways you can do this, right? First, you can look at how many terms are there here in my binomial expansion that I'm working on right now. How many terms are there? How many terms are there? 6 terms. Okay? Expansion of 5 tells you you're going to have 1 more term than the total exponent number, so 6 terms. So you can count down 6 levels. 1, 2, 3, 4, 5, 6. Okay, you can count down the number of levels as there are terms. And these would be your numbers. Or if you don't want to count them, you could also look at the level that has what as its second exponent? 5, because 5 was my total exponent value, and you can look at that level. In either case, what are your what are your coefficients going to be for this expansion? We just filled them in on that chart. 1, 5, 10, 10, 5, and 1. There should be exactly the same number as there are terms. Then the last step here is to clean up. Okay? This is not a very nice looking binomial expansion. Notice there's also not any plus or minuses in there. So you need to just clean this up. Okay, so here, this is really 1 times x to the 5th times y to the 0. Y to the 0 kind of goes away, so what's my actual first term? Just x to the 5th. You don't have to write the 1 in front. You can if you want to. Okay, then this one is 5 times x to the 4th times y, so 5x to the 4th y. What do you think goes in between these two terms? Plus. Okay, this is positive because there's no negatives in there, so put in a plus. What would your next term be after it's cleaned up? 10 x cubed y squared plus 10 x squared y cubed plus 5 x y to the 4th plus y to the 5th. Okay, that is the binomial expansion of x plus y quantity to the 5th power. Yes, ma'am?
Do you leave it like the first one? Is that wrong? Like, so you put like pluses, but like...
If you put in the pluses, it would technically be correct. And it will work because there's no other numbers in here. But eventually, we're not just going to have plain x and y. We're going to have numbers and stuff in there, so it has to be kind of simplified.
When could it be negative?
I'm gonna show you when it can be positive, it can be negatives. You're not always just gonna have a plain x and a plain y. Okay, sometimes it's gonna be numbers in there. You could have positives, you could have negatives, you could have different exponents, okay? We will get to those. Can we please get off of the cell phones? Okay, let's try another one. Number 5. Okay, and now that we've established this pattern, it'll be a lot easier to go and fill them in. Okay, but that one was the longest because I had to show you what all the pattern was. So for example, number 5, now I'd like you to expand x plus y to the 6th power. So in theory, you could take this whole big thing and multiply times x plus y. Or it's easier generally to use that pattern. Okay, so first thing you're supposed to do is what? Figure out number of terms. How many terms will there be for this expansion? X1 to 6 means how many terms? 7 terms, so put 7 spaces. If you have exceptionally large handwriting, this is the time to try to condense it. Okay, because if you have like 3 terms up here and then 4 down here, it gets very confusing. So try to make it all on one. Then step 2 is you're going to put in your first term, and it is doing what? Increasing or decreasing exponent values? First term is decreasing. Okay, so what x value should I start with here? X to what power? 6th. Then x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, x to the 0. What's my next step? Second term, increasing. Okay, and the reason I didn't write x and y here is because sometimes it's not just going to be x and y. Okay, so the second term is the y. It will be increasing in exponent value. What does it always start with? 0. So y to the 0, y to the 1st, y squared, y cubed, y to the 4th, y to the 5th, y to the 6th, and you can always check to make sure that those exponent values add up, that their sum is your total. So at any location, the sum of these exponent values should be equal to your total. What's my next step? So I put in terms, then what do I want? Coefficients from Pascal's triangle. Okay, so Pascal's triangle coefficients. If you have this right here, it should be nice and easy. Okay, if you filled it out far enough. What are your Pascal's triangle coefficients going to be here? The first one is always what? 1. The second one always matches the total. So those ones are always really easy. Then you kind of need to have the triangle. So what's after 1 and 6? 15, 20, 15, 6, and 1. And then the last step is to clean up. Okay? So if we clean this up, the 1 is basically going to go away. The y to the 0 is basically going to go away. Your first term is actually x to the 6th. 6 times x to the 5th times y gives you plus 6x to the 5th y plus what? 15 x to the 4th y squared plus 20 x cubed y cubed plus 15 x squared y to the 4th plus 6 xy to the 5th plus y to the 6th. This is the correct binomial expansion. Try to show as much work as you can because there's going to be a lot of points wrapped up in each answer because each one has to have the right coefficient, it has to have the right exponent values for the first and second terms. Okay, so there's going to be a lot of points tied up in just minor details. Yes. Let me know when you're ready. Yes.
Will they always be adding together?
They will not always be plus in between. In fact, the next one I'm going to show you how it could possibly not be addition. The reason that these are all addition is if you think about it, if you're multiplying things that are plus and plus and plus and plus, you're always going to get positives, okay? It's possible to get negatives, though, and I'm going to show you one just like that in just a second. Are we all caught up? Yes? Raj? Caught up? Yeah? Okay, next one. I only have 2 more. Okay, for example number 6. Example number 6. I would like you to expand x minus 2y cubed. X minus 2y cubed. X minus 2y cubed. So, first thing you want to figure out is number of terms. So, how many terms are there here? Number of terms is always 1 more than the exponent value, so this is going to have 4 terms. 4 terms. Okay, first letter is doing what? Or first term is doing what? Is it increasing or decreasing? Decreasing. Okay, now, up until now, I wasn't super picky about this, but starting now, since it's not just a plain x and a plus plain y, okay, I would like you to write things in parentheses. So what's the actual first term here? Just x. So you're going to write x, and then I want you to decrease from there. So x to the 3rd, and you do need to write what the first term is in parentheses. So this is your first term. Would you all agree that negative 2y is your second term? Okay. I put this in parentheses because things like this, the negative and the 2, have to be in parentheses before you can take the exponents to it. So first one, x to the 3rd. Then x squared, x to the 1st, and x to the 0. Then we want to put in our second term doing what? Second term is increasing. So what is my second term technically? Negative 2 and y. Negative 2y to what power? 0. Then negative 2y to the 1st. Make sure that you're putting these in parentheses because really the first power has to go to the negative and the 2 and the y. Negative and 2 and y all to the 2nd. Negative and 2 and y all to the 3rd. Then next step, you want to put in your Pascal's triangle coefficients. So triangle coefficients. What would the coefficients be for a 3rd level? 1, 3, 3, 1. And eventually ones like this, you're probably going to memorize 1, 3, 3, 1. Okay, that one's pretty easy. You'll probably memorize it. If you don't, you look on your Pascal's triangle, find the one that has 4 spaces, fill them in. Then the last step is to clean up. I'm going to show you. Okay, so here when you're cleaning this up, this is really 1 times x to the 3rd times what's negative 2 to the 0?
1.
What's negative 2 to the 0 power? 1 times what's y to the 0 power? 1. All these 1's basically go away, and your first term is just x cubed. Your next term, you're really multiplying 3 times x to the second times what's negative 2 to the first power? Negative 2. And what's y to the first power? Just y. When you multiply all this together, what does that give you? 3 times x squared times negative 2 times y. Minus 3 times 2 is 6x squared y. You cannot leave these separate. It's not 3 times or 3 minus 2. It's 3 multiplied by negative 2. So this is where we can possibly get negative coefficients. Then this one is going to be 3 times x times what's negative 2 squared. Positive 4 times y squared. You multiply all that together, what do we get? 12xy squared. What is wrong with the way I wrote that right now? It doesn't look like a 12? Okay, besides my lovely handwriting, what did I forget here? A plus. Okay, if it's positive, you have to put in the plus. And then finally this one, 1 times what's x to the 0 is 1. What's negative 2 to the third power? Negative 8 times y to the third. So what's your actual last term here? Minus 8 y cubed. If you notice, when there's a subtract in between your original binomial expansion, your terms will always alternate. It always starts positive, then negative, positive, negative. They always alternate each. This is your binomial expansion. If you give me this, I'm going to mark it wrong because it's not simplified. Okay, last one, I promise. And number 7. If I give you 3x plus 2y raised to the 8th power and just ask you to find the first 2 terms. I do not want all the terms. By the way, how many terms would there be here?
9.
There would be 9. I do not want all 9. Okay, I just want the first 2. So I'm going to fill in the first 2. I am making these lines rather large on purpose. These are going to be kind of complicated terms. So first thing you do, figure out the number of terms. I'm finding 2 here. What do you do with your first term? Put the parentheses around it, right? And what is it doing? This 3x is doing what? Is its exponent increasing or decreasing? Decreasing. What does it always start with? Total value. So it starts with the 8. And then your second term would be 3 and x to the what power? 7th. Okay, what is your second term doing? Is the 2y going to be increasing or decreasing? Increasing, it always starts with what? 0. And this would be 2y to the what power? First power. How do I know what my coefficients are? What's the first coefficient of any binomial expansion? A 1. What's the second coefficient?
8.
The total exponent value. So 8. So did you really need to get your pattern out? No. Okay, you just have to memorize those things. Then you actually do have to multiply here. Okay, I will let you use calculators for this. So it's not going to be that bad. So really, this is going to be 1 times 3 to the 8th power times x to the 8th times 2 to the 0 is 1 times y to the 0 is 1. 3 to the 8th power is actually equal to 6,561. So 6,561 x to the 8th. Everything else went away. You can use calculators on this. This one, you're actually going to be multiplying 8 times 3 to the 7th times x to the 7th times 2, because 2 to the 1st, times y. Multiply all this together. 3 to the 7th is actually 2,187. So when you multiply, you're going to have to multiply 8 times 2187 times 2. So you will get very large numbers, okay? The actual answer here is 34,992 x to the 7th y. So you do have to actually do this multiplication. You can use a calculator. Did I forget anything else? Nope. Make sure you put the plus in there. Those are the first two terms in that binomial expansion. So just be happy that I didn't ask you for all the terms, because that would be a lot. Okay? Homework for this is going to be worksheet 1. It's in your green book. You're doing numbers 1 through 10. Okay? Make sure when you're looking for worksheet 1 that you realize we are on unit 11. Okay? So you're going to get your green books. Worksheet 1 under unit 11. I'm not going to tell you the page number because some of them are numbered a little bit differently. Okay? But you guys are working on worksheet 1 from unit 11, numbers 1 through 10. And that's it.